How ChatGPT, Claude, and Gemini actually work, explained simply. You type a question into ChatGPT, and it writes back a perfect answer. It writes essays. It writes code. It explains complex topics like a professor. But how? What's actually happening inside? Is it thinking? Is it understanding you? The answer might surprise you, because the entire technology behind every AI chatbot is based on one incredibly simple idea. And in this video, I'm going to break it down step by step so you actually understand how these systems work. ChatGPT, Claude, and Gemini are all what we call large language models. Let's break that name down. Language, because they work with human language, text. Model, because they are mathematical representations of patterns in language. And large, because they are trained on an enormous amount of text data and have billions of mathematical parameters. GPT-4 is estimated to have over 1 trillion parameters. Claude and Gemini are similarly massive. But what does parameter actually mean? Think of it like this. Imagine a musical instrument. The more strings or keys it has, the more notes it can play. Parameters are like those keys. The more parameters a model has, the more patterns it can recognize and the more nuanced its outputs can be. But here's the key insight. These models don't store information like a database. They don't look things up. They compress patterns from their training data into mathematical weights. And then they use those weights to generate new text, one word at a time. So how does an LLM actually generate text? It does one thing, and one thing only. It predicts the next word. That's it. Every single word that ChatGPT writes is the result of it asking itself one question. What word is most likely to come next, given everything that came before it? Let me show you. If you type "the cat sat on the model doesn't understand what a cat is. It doesn't know what sitting means. It doesn't have a mental image of a floor. What it does have is mathematical weights that tell it. In the context of "the cat sat on the most probable next word is floor. Maybe with a 42% probability. Mat might be 31%. Couch might be 18%. It picks the highest probability word. Then it adds that word to the sequence and does it again. The cat sat on the floor, and now it predicts the next word. The cat sat on the floor and looked, next word. It keeps going, one token at a time, until it decides to stop or reaches its limit. This is called autoregressive generation. Auto because it's automatic. Regressive because each prediction depends on everything that came before it. One important detail, these models don't actually work with whole words. They work with something called tokens. A token is a piece of a word. The word understanding might be split into 3 tokens: under, stand, and ing. The word AI is just one token. Even spaces and punctuation are tokens. Why split words into pieces? Because it makes the model more efficient. Instead of memorizing every possible word in every language, it learns patterns at the subword level. This is how a model can handle words it has never seen before. It breaks them into familiar pieces and predicts from there. Now the big question, how does it learn which words go together? This is where training comes in. Training is the process of showing the model billions of examples of text so it can learn patterns. Think of it like teaching a child to read. You show them thousands of sentences, and eventually they learn which words go together and which don't. For an LLM, the training data is massive: books, Wikipedia articles, websites, code, conversations, scientific papers. Hundreds of billions of words from across the internet. During training, the model looks at a sentence with one word hidden and tries to predict it. If it guesses wrong, it adjusts its internal parameters slightly to do better next time. This happens billions of times. Each time, the model gets a little better at predicting the right word. After months of training on thousands of powerful GPUs, the model develops an incredibly detailed understanding of how language works, not in the human sense, but in the mathematical sense. It knows that king and queen are related, that Paris is the capital of France, that hot and cold are opposites. Not because it understands these concepts, but because these patterns appeared consistently in the training data. The technology that makes all of this possible was introduced in a 2017 paper by Google called "Attention is All You Need." It's called the transformer. Before transformers, AI models processed text one word at a time, sequentially. The problem was, they forgot what came earlier in the sentence. Transformers solved this with a mechanism called self-attention. Here's how it works in simple terms. When the model is choosing the next word, it doesn't just look at the last word. It looks at every word in the input simultaneously. Each word gets a score, an attention weight, that tells the model how important that word is for predicting the next one. For example, in the sentence "the cat, which was very old, sat on the mat," when predicting sat, the model needs to pay attention to cat, not old. Self-attention allows the model to figure out which words matter most for each prediction. This is why ChatGPT can write long paragraphs that stay on topic. It's not just looking at the last few words. It's considering the entire context at once. This was the breakthrough that made modern AI chatbots possible. After the initial training, the model is good at predicting text, but it's not yet a helpful chatbot. It might generate toxic content, make things up, or just complete sentences without being useful. This is where fine-tuning comes in. Fine-tuning is like additional training on top of the base model. For ChatGPT, Claude, and Gemini, the companies use a technique called reinforcement learning from human feedback, or RLHF. Here's how it works. Humans write example conversations showing what a good AI response looks like. The model generates multiple responses to the same prompt. Humans rank those responses from best to worst. The model learns from these rankings. It learns to generate responses that humans prefer. This is why ChatGPT sounds helpful and conversational. It's not just predicting text. It's been trained to predict text that humans find useful, accurate, and safe. The same principle applies to Claude and Gemini, though each company uses slightly different techniques. One thing that surprises people, these models don't actually have memory. They don't remember your previous messages. So how does ChatGPT seem to remember what you said earlier in the conversation? The answer is context window. Every time you send a message, the entire conversation, including all your previous messages and the AI's previous responses, gets sent to the model as one long input. The model sees everything at once. It doesn't remember, it just reads the whole conversation each time. The context window is the maximum amount of text the model can look at once. GPT-4 can handle about 128,000 tokens. Claude can handle 200,000. This is why long conversations eventually lose coherence. The early messages fall outside the context window, and the model can't see them anymore. Now you might wonder, if it's just predicting words, why does it sometimes make things up? This is called hallucination. The model doesn't know the difference between true and false. It doesn't have a fact database. It's just predicting what words sound right together. If the training data contains contradictory information, or if the question is about something very recent that wasn't in the training data, the model will still generate an answer, because that's what it's designed to do. It fills in the most probable text, even when that text is wrong. This is why you should always verify important information from AI chatbots. They are incredibly useful tools, but they are not infallible. So let's put it all together. ChatGPT, Claude, and Gemini, they are large language models. They were trained on billions of words to learn language patterns. They use the transformer architecture with self-attention to understand context. They predict the next word, one token at a time. And they've been fine-tuned with human feedback to be helpful and safe. They don't think. They don't understand. They don't have feelings or opinions. They are incredibly sophisticated pattern matching machines that generate text by predicting what comes next based on everything they've learned from human writing. And that's both their incredible strength and their biggest limitation. If you found this helpful, subscribe to AllAboutAIVerse for more visual explainers on how AI actually works. We cover everything from neural networks to computer vision to the latest breakthroughs. Like, share, and leave a comment if you have questions. See you in the next one.